Hello and welcome back to California Geology. I am Dr. Robert Lopez, and today I want to talk about the Medicine Lake Highlands, which includes the Medicine Lake Volcano and the Lava Beds National Monument. Now this area sits about maybe 50 kilometers from Mount Shasta. It's to the east of the Shasta area, and it's on the border between the Modoc Plateau province of California and the Cascade province in California. Also, this Medicine Lake volcano sits in a region where there's depression, and the volcano is actually undergoing east-west extensional deformation. In other words, there seems to be some sort of tensional stress pulling apart in an east-west direction, which probably explains the mafic magma coming up from the mantle and producing these basalt lava flows that we see here at the Medicine Lake Highlands region. Medicine Lake volcano itself is actually a shield volcano, but it also has lava of different chemistry. There's andesite lava and even rhyolite lava. So it's kind of we call it a bimodal, where there's both felsic and mafic lavas, but there's also some intermediate lavas in here as well. Now, this part of California sits nearly at the Oregon border, right? There's this Tule Lake region here, the Klamath Basin, and the Cascade Range should be back over here. Now, I'll look at the Medicine Lake Caldera region first, the Medicine Lake volcano, then we'll talk about the lava beds. Again, a recent paper published in 2010, a geologic map on the Medicine Lake volcano by Julie Donnelly Nolan, talks about how this Medicine Lake volcano is undergoing east-west extensional deformation, probably due to extension that's happening more in the Basin and Range province and this Modoc Plateau region of Northern California, thinning the lithosphere there. And then Medicine Lake volcano is behind the Cascade volcanic front. So again, it's on the border between that Cascade province and the Modoc Plateau province. And there's a new age in this paper by Julie Donnelly Nolan, saying that the earliest volcanic activity at Medicine Lake volcano is 500,000 years old. Our textbook says 700,000 years old, so we're going to use the new data of 500,000 years there for any quiz questions. Now, again, Medicine Lake volcano is a shield volcano, primarily basalt, although there is some andesite lava flows and some felsic domes you see over here. This picture is taken from the north, looking back to the south of Medicine Lake volcano. And like the Hawaiian volcanoes, which are shield volcanoes, they do have summit calderas. And so we saw that in our Medicine Lake caldera, there is one right in here, and that's where the Medicine Lake occurs. Now, for these types of volcanoes, remember, mafic lava is pretty runny, it's fluid, it can flow large distances, 20, 30, 40 kilometers away from the vent to make these very broad and wide volcanoes. So again, here's a caldera where Medicine Lake sits, and then here's some of the more felsic. You can see these young felsic rhyolite flows here. Again, here's the Medicine Lake volcano in comparison to Shasta. Actually, Medicine Lake volcano is more voluminous than the Shasta volcano, and it's covered by this vesicular basalt, primarily basalt lavas. Now, some of the younger eruptions in the Medicine Lake volcano, your book says that they occurred between 200 to 300 years ago. Well, there's some better numbers. They're actually a little bit older than that. This is Little Glass Mountain and Glass Mountain. And both of these date to about maybe 900 to about 1,000 years ago. So Little Glass Mountain has a new age of about 1,065 years old, whereas Glass Mountain, the bigger one there, has a date to 950 years old, right? So that's older than what Hardin or your textbook says. So we'll go with those older ages of 950 years for Glass Mountain and 1065 years for Little Glass Mountain. Also, in your textbook, Hardin mentions that there's a basalt lava flow from Mammoth Crater that has an age of about 100 years old. Well, the U.S. Geological Survey says that that this mammoth crater probably erupted for a span of 100 years. But the flows are actually considerably older. They're more in the order of maybe 2,000 to 3,000 years old. So there's an error there in your book as well. But this is Mammoth Crater, and some of the trees down here are like 40, 50 feet tall. So it's a pretty large crater in the Medicine Lake volcano region. Now, the other place I want to talk about is this Lava Beds National Monument and the Modoc Plateau. So I'm showing these pictures because I want you to see the flat topography covered by these basalt lavas. One of the questions I have on the quiz or on the exam will be, why is the Modoc Plateau flat? Remember, plateau means an elevated flatland. Well, it's flat because the lavas are runny, they're fluid, they're gonna flow long distances and spread out. So that's what we're seeing here in this region, the flat topography. Occasionally you'll see these cinder cones like Scontian Butte here, but for the most part you have this flat topography. And we talk about Mammoth Crater. So the lava beds is actually famous for a couple of reasons. One is in the 1870s there were these Modoc Wars, and in the winter of 1872 and 1873, a band of about maybe 150 Modoc Native Americans, including women and children, held off about 650 army troops. And they could hide in these fissures along lava flows. They could escape in lava tubes. And the only way they were captured was they were betrayed by one of their own. In fact, these Modoc Wars of the 1870s were the last battles between the U.S. and Native Americans in this country. Also, this Lava Beds National Monument is famous for lava tubes. There are many lava tubes. Here's a hiker going. There's trails that lead in there. Many of these lava tubes, the way they work is as the lava flows down, since it's fluid, the surface may cool more quickly because it's in contact with the air, and the bottom cools quickly because it's in contact with the ground, but it leaves an insulation, and it acts in fact, this insulation acts like a pipe where the lava inside remains warm and hot, and it can flow for long distances, just like water can run under ice, right? So under ice, water can flow. Same thing is happening here. In this case, it's lava flowing, and this is how these lavas can flow 30, 40, 50 kilometers away from the vent, right? And then because the ceilings of some of these lava tubes collapse, it makes entrance to these lava tubes accessible. In fact, here's an example. This is actually a subway cave over near Lassen Volcano. But here the ceiling collapsed, and I took my class, this is maybe like 8 years ago, and we walked through these lava tubes. It gets pretty dark in here. Here's a couple of students, but this is an example of a lava tube there. So again, famous for these lava tubes. And remember, the ages are a little bit different in terms of what Hardin is giving you in your textbook. In 1989, this volcano had a series of maybe tens to several hundreds of earthquakes that occurred in the volcano, indicating that magma was moving. The USGS has been monitoring it, but nothing has really happened since then. But it just reminds us that this is an active volcano, and it will erupt sometime in the future. Well, let's stop here.